Hey there, mathletes. It's time to get back in the swing, and we're going to talk about the distance formula in this video. So before we really start with the distance formula, I would like to start by talking about something that you are familiar with, okay? Almost all of you have had some experience with something that looks like this. We see a segment that has been drawn in the coordinate plane here. But we're going to actually add a couple things to the segment and find the length of the segment by stuff we add to it. Okay, so remember, our goal in this exercise is to find the length of this segment right here. Okay, so what if we add a horizontal line from the leftmost point to the rightmost point? Okay, so all we did here was add something that was horizontal. And then let's also add something that's vertical, okay? From the topmost point to the bottommost point. Now, most of you would say, oh, look, we've made a right triangle. And indeed we have, because we've done something completely horizontal and completely vertical. And this should be straight up and down. And of course, it's a little wavy because I'm a little human. All right, so knowing what we know about a right triangle, we would probably be able to find what the length of this hypotenuse is if we know the lengths of these two legs of the right triangle. Would you agree? Let's give it a shot. Okay, so can you tell me what this length is? You should be able to say, oh, well, this is 7 and this is 1. So this distance is going to be 6 units, right? Okay, and then for here, if I'm looking at the distance between here and here, well, let's see. This is from -3 all the way over to 5. So 3 plus 5, that's 8 units. And then could you say then that the hypotenuse could be found by doing a squared? Okay, so do you think we can say then that we can find this distance, the hypotenuse, by doing by calculating a squared plus b squared is equal to c squared, where c is the hypotenuse? And then we could just put in the 6 and the 8 for the legs. Let's see, what does that give us? 36 plus 64 is equal to c squared. 36 plus 64 is equal to c squared. That's 100. Is equal to c squared. So c here is going to equal plus or minus 10, but since we're talking about a distance, it's going to be the positive 10. Okay, all right. So simple Pythagorean theorem problem, right? Well, this is actually where our distance formula comes from. So when we see the distance formula, it's kind of looking a little complicated, right? But really all we're doing when we find the distance formula is exactly this, okay? So let's say I didn't know exactly what this and this value is, but no. Let's say I didn't really know what these are. We're just generalizing these two values, okay? Okay, so when we're looking at this and we want to generalize this for anything, what we can do is say that this distance is really y2 minus y1. One of the y values, subtract the other y value, and we're going to get this value here, okay? Now, over here, this then is going to be x2 minus x1, same thing, all right? And so we can kind of sub this into, I'm going to say c squared is equal to a squared plus b squared, all right? And I'm going to put in I'm going to call c the distance here that we're looking for, okay? So I'm just going to replace this with d to represent distance, okay? And then here, let's generalize one of our legs. So let's just say that this first one is going to be x2 minus x1. Okay, and then that's going to be squared. And then this one's going to be y2 minus y1. And so my distance squared is going to be the difference of my x's squared plus the difference of my y's squared. Okay, but most of the time I'm not really interested in the distance squared. I'm interested in the distance. So I'm going to take the square root of both sides to say the distance is going to equal the square root of that whole thing. Let's see it. Awesome. Okay, so we can say then that the distance formula is derived from what? The Pythagorean theorem. Okay, so let's take a second and look at some examples using the distance formula. You ready? Okay, I've got 4 different examples here of problems that need the distance formula. All right, so let's go ahead and try these and see what happens. All right, so let's go ahead and remember what the distance formula is. D is equal to the square root of the difference of the x's squared plus the difference of the y's. Okay, the difference of the x's squared plus the difference of the y's squared. All right, so let's go ahead and sub this stuff in. So let's go ahead and choose our x's. We have an x2 and an x1, so let's put those in here and subtract them. And then I've got 2 y values, y2 and y1. Let's put them in here and subtract them. All right, so now let's go ahead and add together and square, add together and square, and then take the square root, right? So this is going to be 16 squared plus 12 squared. All right, so 11 minus negative 5 will give us 16, and 9 minus negative 3 is going to give us 12. So squaring 16 is going to give us 256. Squaring 12 is going to give us 144. 256 plus 144, this is going to be the square root of 400, which is actually a nice perfect square. It's 20 times 20. So we end up with here, the distance between these 2 points is 20 units. Okay, how about this one? Same idea, you try this time. Pause the video, see how you do, and then start it up again. Okay, let's walk through it. Hopefully this all went smooth for you. Okay, so let's sub in our x's. 2 minus negative 3. 2 minus negative 3. Now sub in our y's. 6 minus negative 4. 6 minus negative 4. So this becomes a 2 plus 3, which is 5 squared. This becomes a 6 plus 4, which is 10 squared. So 25 plus 100 gives us the square root of 125. And remember, we're going to want to break that down into perfect square factor and non-perfect square factor. So we'd have the square root of 25 times the square root of 5. And we know that the square root of 25 is 5. So our answer is going to be 5 times the square root of 5. Awesome. All right. Here, when you're finding the length of the segment, you can either do this by creating a triangle and using the Pythagorean theorem, or you can find the endpoints and then go ahead and use the distance formula. It's a matter of preference, whichever one you like, okay? So I'm going to do one each way, all right? So I'm going to do the first one by making a triangle. I'm going to choose one of the points and create a vertical line and a horizontal line to get to the other point. Okay, so this one, I'm going to do this vertical line down and this horizontal line over. All right, and then I'm just going to count units. How many units is this vertical line? Well, there's 1 plus 2 more, so this is 3 units. How many units is the horizontal line? Well, that's going to be 3 units plus 6 units, or 9 units. So now I've got these 2, I can plug into the Pythagorean theorem and find the third. So I'd find d is equal to, well, d squared is equal to 3 squared plus 9 squared, right? And then that's equal to 9 plus 81, which is 90. So d is going to equal the square root of 90, which is the square root of 9 times the square root of 10, also known as 3 times the square root of 10. Okay, for the second one, let's find the coordinates of the endpoint. So notice this one has a scale that's different on the y-axis, and we need to remember that. We need to take that into consideration. So the coordinate here is -4, -15, and the coordinate over here is 7, 18. So then I can go ahead and substitute these values, my x values and y values, into the distance formula to go ahead and create the relationship that's going to give us the distance. Okay, so let's do the x's first. x2 minus x1. 18 minus -15. What is that? I think it's 18 plus 15, which is 33. All right, and then 7 minus -4, also known as 7 plus 4, which is 11. Okay, 33 times 33 is 1089. So now I'm going to add these two things together. 1089 plus 121, 1210. All right, and so I notice 121 is actually 11 squared. So I can say that that's a perfect square. So that's going to be the square root of 121 times the square root of 10, also known as 11 times the square root of 10. All right, so those are good examples for distance formula. The next thing we're going to jump into, so exciting, is going to be equations of circles from a center and a radius, and actually pulling the center and the radius from the equation of a circle. So I think you'll find it pretty easy, but tune in because that's what's next.